Does that mean anything to you? Scale factors?
I've heard it before, but I don't remember the name.
So let's
Or
let's
like, I don't
let's take a
remember.
really simple graph here. I'm going to put a point at 0, 0, and then another point at 0, 2, and then another point at 3, 0. Now we were doing geometry last time. What shape is this?
Triangle.
Triangle. Okay. So now here's what we're going to do. We're going to make a table. Okay. And this is the original, and then we're going to do the new. So the original is 0, 0. The order doesn't matter, 3, 0, and then 0, 2. And then for the new, we're going to use a dilation of 2, or a scale factor of 2. Okay, so that multiplies everything by 2.
Oh.
Okay, so every number, now the zeros are easy, right? 0 times anything is 0, but every number you multiply by 2. So it's going to be 6, 0, 0, 4. And we're going to plot the new ones in blue. Okay, so 0, 0, 6, 0, 0, 4.
Got it.
Now, when I draw this, and you don't have to do any yet, but do you see an increase in the scale factor?
Yes, I guess.
Okay. Now, we were doing areas of triangles last time. Is that right?
Yes.
Okay. Can you give me the area of the triangle in red?
What is area equals base times height
Divided by 2.
divided by 2.
Okay.
So that would be 3 times 2 divided by 2.
Okay. And what does that equal?
3.
Okay. Now do the one in blue for me, please. Give me the area of the triangle in blue.
6 times 12 squared meters.
Okay. Yeah, we don't have a, but yeah, 6 times 4 divided by 2. So what's interesting is the dilation of 2. Did the area go up by 2?
No.
What did it go up by?
3. 4.
Yeah, it went up by 4. That's interesting. We'll think about that a little bit here. So let's do another dilation, okay? So I'm gonna make this one a little bit more difficult for you just to see how much understanding you have. Here's a point, here's a point, here's a point, and here's a point. Now assume these are all 1. I want you to give me the ordered pairs for A, B, C, and D in this problem. And you probably don't want to copy this down. It's probably too much to try to copy down, but.
So give you the dilation or?
No, give me the ordered pairs. Tell me the ordered pair for A.
Oh, B and A, C and D.
Okay, so when I say ordered pair, that's what I'm trying to gauge, like what you know and don't know, because we haven't worked together that long. The origin is right here at 0, 0. How do you get to A from the origin? Like, imagine you're driving or walking. How would you get there?
Drive right and then up.
How much right?
4.
So 4 right and 1 up. So the ordered pairs always go first it's right and then left.
Oh,
comma,
X,
up,
Y.
and then down. Yes, but X means right, left, up, down is the. Okay, so how about B? What is B?
B is 4, 4, 5. No, 4, 6.
So you count from
Five.
Yes, 4, 5. Okay, give me the ordered pair for C or D. Either one I'll take.
2, 2, 1 for D.
So you're going left. So left is negative.
Oh, negative 2D, or sorry, negative 2, negative, or no, negative 2, 1.
Positive 1, good. And then how about for C?
C is negative 2, 3, 5.
like that.
Yeah.
Okay, now let's say it's a dilation this time of 3. Let's say dilation of 3. Okay, so you have to multiply each of these x values and y values by that number. Can you do that for me, please?
Yep.
And you can give me all, you can give me the answers as you go, or you can wait till the end.
Mm. Okay, so A would be 12.3.
Okay,
B would be 12.15.
good,
C would be, I think, -6.15.
good. Keep going.
And then D would be -6.3.
Good. Okay, very good. All right. Now I'm going to new share a graphing tool that I really like, although I don't know where it went. Huh. Give me a moment here. Why isn't it showing up? Okay, sorry about that. Technology doesn't always work the way I want. Okay, new share. Sorry, just a moment. There it is. All right. Have you ever seen desmos.com/calculator?
No.
Okay, so I'm going to put, sorry, I don't mean to keep doing that. I'm going to put a link to this in the chat. This is a really cool tool. It's actually not a calculator, it's a graphing tool. I don't know why they called it calculator, but that's beside the point. So I'm going to graph the original points, 4, 1, and I'm going to label it. So when you label it, it puts the ordered pairs there.
Oh.
Now I can also do this. I can also put in A for the ordered pair, but I'm going to leave it with the well, actually, let's. What do you prefer, A or the ordered pair?
A.
Okay. So let me get the next one here. This is B. C is -2, 5. And then D is -2, 1, like this. Okay. Now, can you visualize the box that connected them?
Yeah.
Okay, because what I can't do is I cannot connect the lines easily, but what I can do is do give you the new points. Okay. Now the new A is 12, 3. Now, did you talk about in class the idea of how you label the new points? Do you use a little tick mark on them?
Uh, we usually just kept going with E, F, G, A, B, C, D, E, F, G, H, I, J, K through the alphabet.
Okay, I'm going to use these primes. This is the notation you'll see. I know you're probably more comfortable with the other way, but just go with it for now. Don't make a big deal out of it. It's really not that. Now this one I can't find. 1215 is not here, so I got to zoom out. Okay, there it is. All right, and then -6, 15. So if you ever don't have graphing calculator, or I'm sorry, graph paper, you can always go to this tool to graph. Okay, and it's very visual. It's got nice colors, things like that here. All right, so here's what I'm going to do. I'm going to snip this into our workspace, but we'll probably use Desmos a lot if we continue to work together, because I really like this tool. I think visualizing it is super important here. So let me go back to the other screen. Okay, now can you give me the area of the original?
We got
So it's
Desmos does it
base
differently.
times height.
Oh, Desmos does it differently because we had a different one earlier.
No. This is the drawing. It was this is right. It was right
We had
for
different. Oh, was it the
it's
exact
actually
same?
it's the exact same. I've just got this. Its zoom is different because I want to get the other points in there. So
Okay.
just count the boxes.
It's got 6 times 4, which is 24.
It's not at the bottom is you've got the bottom right 6 and then times 4 is 24. Good. Okay. So 24. Now the bigger one, let you I'm gonna I can get the right thing here. Okay, if you could give me the area of the bigger one.
Three. Uh, 18 times 18 times 13.
I think it's 12. It's because you're starting at 3 and you're going up to 15.
Oh,
So 15 minus 3 gives you 12. The other one was right though. It's 18. So go ahead and multiply those together, please.
okay. 216 squared.
216. Good. Okay. Now, the next thing I want you to do, and there's a reason for this, take the 216 and divide it by 24. So how is your long division?
Good.
Okay. So are you comfortable doing 24 into 216?
Yep.
Okay. Can you do that and give me the answer?
Yep. 24, 48, 72. 72 plus 24. 72 plus 24 is 96.
I'm asking for how many times 24 goes into 216.
Yeah, I'm counting up by
Okay.
24.
Okay. Yeah, I mean you've done 4 times 24 is 96. It's a lot bigger than that. So you might want to go to 8 times 24, which is double that.
4, 8, 16, 24, 8, 16, 24, 32.
So this is 192, which is still too small. So let's do
Okay.
one more 24.
9, 18, 26, carry the 3, 18, 21, 216. Or,
Good. So it goes in
yeah.
9 times. Okay. So here's what I want to summarize the 2 problems we've done, then we'll move to another worksheet. So we did a triangle problem. We used a K factor of 2. And actually, let me go back up and grab the numbers because I don't have them here. There they are. So the first area we found was 3, and the next area we found was 12. 12 divided by 3 is 4. Okay. Then we did a square with a K factor of 3, and we found that the first area was, sorry, I'm losing track of my numbers here, 24 and then 216. And what was really interesting here is that 216 divided by 24 is 9. I want you to look at
Oh,
this number. I'm sorry, that's the wrong number. This number and this number, this number and this number, and tell me if you see a pattern.
they,
How,
they're,
how do you,
you multiply by 2
does
and
that
then
work for this
3.
one though?
No.
So it's actually a power of 2.
Oh,
Okay. And you'll see that again in geometry, but for now, we're just going to go with that. All right, so some new problems here. Um, these are kind of how they usually start. It's a straightforward rule that you probably saw in your class. Do you get homework each night, or do you have problem sets you need us to work on?
um, in earliers we did we did notes in class and then homework at home, but now we do homework in class and then notes at home. So
Oh, that's right.
no,
You're in the flipped classroom. Okay. All right. Well, if you ever need us to do any homework problems, like anything you didn't get done in class or unsure about, just let me know.
got it.
Okay. So to decide whether something is a reduction or an enlargement, it's very simple. If k is greater than 1, it's an enlargement. If k is less than 1, it's a reduction.
Got it.
So tell me which of these are an enlargement.
1 and 3.
Okay. Which ones are the reductions?
2 and 4.
2 and 4. Good. Okay. Now the order matters. Okay. The order matters. And I'm going to show you an example here with this. And it's like a language thing. You said you like to read
Mm-hmm.
spelling. So our language, English language, is awkward in a lot of ways. It comes up in math and occasionally. So if you go from B to A, which means you start B and go to A, is that an enlargement or a reduction?
Uh, enlargement because yeah, enlargement
That's
because
right, because it's getting
yeah,
bigger. But if you go the other direction, if you go from A to B, what is it?
reduction.
Reduction. So the answer depends on the direction you're going. Do you agree with that? Do you see that?
Yeah.
Okay.
Mm-hmm.
So it's like it could be either depending on how you're wording it. And that's one of those fun things about our language that drives people crazy.
Got it.
All right, so new problem here. We're going to start with A. I want you to give me the 3 vertices of A, please. Those 3 vertices
Um,
in red.
like label them.
Yeah, give me them as ordered pairs.
Uh, at B, C, and D.
Okay, let me be more clear. Let's call this A.
Oh,
Well, I don't like that. I don't like these names. Okay, let's go C, D, E. Do that for me. C, D, E.
mm-hmm.
So give me those ordered pairs whenever you have them.
Give you
Give me the ordered pairs for C, D, and E.
as in like
Okay,
I'm
I'm trying.
confused.
Okay, so C is going, I'll give you the answer for C. It's -3, -3.
The coordinates. Okay.
Coordinates. Okay, yeah. Coordinates and ordered pairs mean the same thing.
Okay.
Coordinates, ordered pair, they're synonyms, math synonyms, we'll say.
Okay. D is 0, 4,
3.
3, 3. Yeah, 3.
Okay, and E.
And then E is uh, 4 and 3, 3. Negative of 4.
-3.
Negative 3.
I know it's hard when it's on a screen. Don't uh, don't don't take too much away from that. Okay, so now let's look at these other 3 points. C prime, D prime, and E prime. I'm going to label those for you over here. So the first one is -1, -1, 0, comma 1, and then 1, comma -1. Now it's usually easier to go from smaller to larger. Okay, and sometimes it's even
Mhm.
easier if you focus in on an ordered pair that's all positives. Meaning, like, how do you go from 1 to 3, Lewis?
You multiply by 3.
Yeah, now does that work for the rest of them? Like, does that work for 0 times 3 to get 0?
Yeah, kind
Okay,
of.
yeah, it does. And then how about the other ones? Is minus 1 times 3 minus 3?
Yeah.
So that is your dilation. Your dilation is k equals 3. But what's really important is that you recognize that's if you're going from the blue to the red. Because if you go the other direction,
Would you
it's
divide?
different. You would divide by 3. It's 1/3. So it really depends on the direction that you're going.
Got it.
Does that frustrate you or does that make math sense?
That makes sense.
Okay, fantastic. All right, let's see what else we got on this worksheet here. Uh,
Inverse operations.
let's go back to the other one. Um, all right, here we go. So give me the ordered pairs for uh, these red dots here. Let's call
Um.
it, let's go
Oh,
C, D, E, and F.
got it. C is -2, 1, or
Negative
negative
one.
1.
Good. D.
D is -2, 1.
Okay. E.
E is -1, 1.
Good.
F is -1, 1.
Negative one.
-1, -1.
Okay. Now I'm going to give you these other ordered pairs here. So I'll do them in the same order: C prime, D prime, E prime, F prime. So we've got -6 comma -3, -6 comma 3, -3 comma 3, -3 comma -3. And kind of like the last one, it's the same scale factor. It's k equals 3 if you're going from the B to the A, that's k equals 3. But if you're
Got
going
it.
the other direction, it's k equals 1/3.
Got it.
All right. So that'll do it for us for tonight.